Hi, and welcome to Programming for Posterity. I'm your host, Nelson, as always, and welcome to the third episode. I think, from my perspective, it's going to be. So, from my perspective, last episode I was talking about the uh, the way we draw walls in the engine, um, and that's the probably the most basic unit of level geometry in this game engine. And now we're going to talk about the map format. So the format on in memory when the game's running, and sort of the we're definitely going to talk about the format of it on disk, but that's very close to the format that it's in memory as well. You'll see when we get into that, and we'll do. I've got a little document prepared with some structure for that, but let me put it first of um, into context of the overview thing that I've showed a few times, right? So you can see we did this last time, right? And maybe we can put a little. We did it, guys. We did this one. Um, and where is the one I was going to do today? This one. Let's say, yeah, right. Oh no, actually, don't put an X there yet. I haven't done it yet, right? That's what we're going to do. That's what we're doing today. Okay. Let me transition back to this for a sec. Okay. So that's the one we're going to do today. Yeah, what's the structure today I'm going to try and follow is firstly I'm going to show you the like the C++ structs for a map, all the things related to maps like the enumerations and structs and stuff. Then I'm going to do a bit of a demonstration and a deep dive on how floor and ceiling heights work between the map format and the engine. And then similarly, we're going to look at light levels, although that's more going to be like between the map and the engine, how light levels work, not how light levels are actually implemented. That's a discussion about the color map mechanism in the game, which we won't go into in this video. We'll do that in a future video. Then we're going to talk about serialization and deserialization of the map files. So I'll show a little bit in like the map editor of like as a level designer how you interact with the map editor to save a map and what it means when you load a map in the game. But we won't go into how that's implemented. That'll be in another video. But the serialization, deserialized, we will go into is the code of actually how the bits get written out when you save a map and how the bits get read when you load a map. And then that leads into the next topic, which is like once you've loaded a map into memory in the game, what do we do with that, right? There's a bit of a gap between that and actually playing the game. So we'll look at like initializing game state for stuff other than level geometry when we load a map, and also including some level geometry and dynamic tiles stuff. This level geometry and that gets initialized when you load a map. And that's also different from when you load a save game, right? When you load a save game, we don't do exactly the same thing. But anyway, I'll make it clear when we're talking about that we're talking about when you don't load from this. Or what stuff, maybe we can look at this stuff. It's just sort of a subset, right? When you load a game, it's a subset of a save game. It's a subset of the stuff you do if you're initializing it without loading a save game. And then another deep dive on the settings for tile depth, and tile depth doesn't mean anything maybe to you yet, so we'll talk about that when we talk about the map format. And then a deep dive on the settings on a marker, and marker maybe doesn't mean anything yet. Don't worry about that. We'll cover that when we talk about the map format. And then that's it. Then we'll do a recap, and that'll be it. Hopefully it's not too long. Okay, so we'll go straight into it. This other scene, what have I got set? I want to show. So now we're in the editor, right? And what am I looking at here? I'm looking at list of tiles. That's not what we need. Let's go straight to map.h. Now this is cool. In map.h, we have, actually, where should we start? We should start at sort of at the bottom, I think. So we have this struct here called map. And this represents, like, this I think should have all of the data when you have a map loaded in memory. All the data for the map is inside this structure, right? Nested inside of these things. That I don't think it contains any pointers or anything like that. All the data is like in this guy. He's maybe a fat boy. Look at that. 115 kilobytes around about, right? Of pure unadulterated map data. This thing called Tile, which is maybe not a great name now, but it's older than the hills. I don't really want to change it now. This is so map width by map. This is another thing that I don't really like about the map format. I got into doing it this way, and then I kind of regretted it, and I wish I had done an array of arrays, but that's okay. It doesn't matter. It's buffer, say, that contains, or it's an array that contains width by height of these tile info IDs. Tile info ID is it used to, in the old days, it used to be an enumeration that had the names of all of the tiles that were loaded from an info file. Like in here, there was one that was called tiles. There isn't anymore. There's no one called tiles. But there used to be hard-coded tiles. And this tile info ID was like a name from that. It was still a number like it is now, but it was like a name. And that would be an index into a hard-coded kind of like list of tiles it's generated by Python script, but it was like C++ generated code and like what would you say? Statically allocated array of all these tile definitions with all the data filled out for them. Not the case anymore. Now these tile info IDs is just a uint16, which is an index into this guy, this thing of tile defs, right? So you can see the names don't quite match tile info ID and tile def. This probably should be called like tile def ID or something, or I don't know, maybe not even. Yeah, maybe tile def index, tile def ID. Doesn't matter. That's fine for now, right? This is an array of indices into this thing, right? And we'll talk about this later. This is kind of an interesting part of that format. So this is so every like tile in the world, right? The coordinates of those map to a tile ID from this thing here. And then similarly, we have this floor H and ceiling H, and these are the same. This is another layer, right? These are different layers of the same map, the same world. So coordinate 0, 0 in this is logically the same place as coordinate 0, 0 in this, logically the same place as coordinate 0, 0 in this, logically the same as coordinate 0, 0 in this, right? This is just telling you different information about the same place. 0, 0 has a tile, coordinate 0, 0 has a tile, coordinate 0, 0 has a floor height, coordinate 0, 0 has ceiling height, coordinate 0, 0 has a light level, right? The reason we do this is different layers. It kind of doesn't really matter that much. I mean, maybe you could get into analyzing the access patterns of these and decide it would be better to have an array of structs rather than a struct of arrays, but I don't think so. I think this is fine, and we like it this way, so I'm keeping it this way. Okay, sorry. So I was talking about the floor heights. This uint8 is, well, I was going to say it's a number between 0 and 255, like it says here, but that doesn't really tell you anything, does it? This is a height. Yeah, well, I was going to say height vertically, but I guess that makes sense, right? It's talking about how high a tile is off the ground, right, vertically. How high the floor is off the ground. So a higher number moves the floor up, and same for the ceiling. Higher number moves the ceiling up, right? If there's a gap in between, maybe you can walk through it. Maybe it's just a building, interior of a building with a ceiling, right? And yeah, okay, so ceiling height, same kind of thing, right? We're talking about, we have variable height and floor, ceiling and floor heights. And then light level is how dark a tile is, right? We just have this, what do you say? We just have this one kind of lighting system where a tile is at some particular darkness level. So the geometry of that tile gets painted at that darkness level, and anything on that tile, like an actor that's on that tile, will also be painted at that darkness level, right? So this is similar to in Doom, right? I guess sectors have light levels, right? I think it's sector wide, and anything in the sector gets painted with that light level, something like that. So that's what this is like. Num tile depth is pretty obvious. It's just how many of these tile depths, because I think is there a max? Yeah, max is 512. Yeah. Okay, so the maximum you can have is 512. I don't think we ever any of the level designers actually use 512 yet. Um, maybe it could be 255, but that's okay. And here we treat this. Look, this is UN16, so actually we could have way more than 512 based on the size of the tile data. Maybe the tile data is too big. That's right. I guess this is the smaller size that it could be that you could have 512, right? And then tile depths are, I'll go and show what that is, because that's actually pretty complicated on its own. A tile depth is, it says for a tile, but now we're talking in a kind of abstract way. We're not saying like, it's not like there's a tile depth for every square in the map, right? The tile depths can be applied to any number of squares in the map. This is kind of like a template to use, right? This is just data that could be used for any tile. But for a particular tile depth, it has a type, and where is the type? Here, it can be a floor, a wall, or a thin wall. Thin wall is something like a door where it has a wall, but not all of the not the entire tile is blocked by a wall, right? So wall is like a cube. Wall will look like this. Right? Wall will look like this in the camera, right? And floor, I guess we can have come up with some equivalent. So floor will look like that, right? Like floor is just empty. It'll draw, if it has a ceiling, and we can talk about that later as well, it's a separate thing. If it has a ceiling, maybe we'll draw a ceiling on the top, and we'll draw a floor on the bottom, like this, right? But we won't draw any walls, right? Thin wall is not the same as either of these. Thin wall is a different thing again, if I show the same sort of diagram here. So thin wall, and thin wall, now it depends whether it's an east-west or a north-south thin wall, right? But see, a thin wall is going to be like this, right? So like the extreme edges of the extreme edges of it, right? We don't draw anything on. It's kind of like the floor in that regard, right? Oopsie, get it closer. It's kind of like the floor in that regard. The extreme edges of we don't draw anything. It's not a solid thing. But through the middle of it, there's this guy, right? There is a wall going through the middle of it. And you could imagine it's the opposite orientation, right? So suppose we call that one a north-south thin wall. There is an east-west thin wall where the wall is going the opposite direction, right? So it's, you can see very faint lines I added there. Actually, you can't see that. Anyway, you can imagine that there's a thin wall that's perpendicular to the one that I've drawn there, right? That's the opposite orientation of a thin wall. And what's that useful for? Primarily, that's useful for doors. That's the way that we do doors in the engine. It's the way that doors were also done in Wolf 3D, I think. So you have that thin wall, and then you like slide it, make it disappear, and then map the texture so that as it's disappearing, it looks like the thing is moving as opposed to it just being like disappeared or reappeared. I don't know. I can't think of, it's too early. I can't think of what the proper word is. So that's what the tile type thin wall means. And so we've got type. Flags is just kind of like a grab bag of random effects that could be attached to a particular tile we use for different things. What's some examples here? Oh yeah, so like don't block sound, don't block vision. This is for the AI. Don't block sound, don't block vision for AI, not for the player. No ceiling. No ceiling means like don't draw a ceiling above this tile. It's outdoors, so you'll be able to see the skybox. Actually, this also means there's some more complicated stuff now. We've got kind of 3D physics going on, so it can affect some other stuff as well. But that's mostly what it means. Door is treated as a door. If it's a thin wall and it's a door, then we do door stuff with it. If it's excuse me, if the flag door is on but it's not a thin wall, then I don't think this does anything. So some of these things on their own don't do anything. You kind of have to know what are the valid combinations, which is it's definitely like a not good API kind of thing. But the level designers kind of understand what the valid combinations are, and they experiment stuff. Push wall is like door, except instead of a thin wall, this is for a real wall. And what it does, if you put push wall on a real wall, when you interact with it, it moves like in Wolfenstein 3, those ones that slide. And I'll go through. Actually, I'm not meant to be doing the deep dive on all this stuff at the moment, am I? So let's not go into too much depth. So we've got these flags. Direction is important, like for the thin walls I was saying, it can be east-west or north-south. That applies for some other stuff as well. Key color is if it's a key door, which particular key is it for? Tag is to do with sort of scripting dynamic tiles or scripting switches and stuff like that. So this is just sort of fully abstract number, but the level designers can hook things up using tags. Exit is if it's an exit, which level does it exit to? Texture info. Oh, so this is all the different textures for a tile. For tile def, we have a low wall, high wall. Oh, sorry, low wall, mid wall, high wall. Mid wall is for like a thin wall for a mid texture. Ceiling is for ceiling. Floor is for floor. Door frame texture is for if this happens, like it's basically if it's a wall and it happens to be to the side of a door, what texture do we use for that face of it that's next to the door instead of the normal one, so that we can have a different door frame texture. This is something that I feel like is always, it has to be a hack kind of in a Raycaster. Unless you wanted to go through and label every individual face of a tile. I don't know anybody doing that. Floor move disk, ceiling move disk. This is about scripting moving tiles. We're not going to go into a deep dive on it now, but we will later. Replace tile def ID is for push walls. So if this tile is a push wall, or it's something that a push wall traverses on the way to finishing its movement, this is the tile def that we will replace this with. That makes sense. So this will point to another tile def in this array of tile defs here. Yeah, it'll point to another one there. Okay, yeah, so that's all the stuff in a tile def without going into a lot of depth on it. Then we have markers. So markers are how we, well, the most important thing is probably that we use them to spawn actors. I'm trying to think if there's other things we use them for. At the moment, there's only two things markers get used for. Actually, we can look at marker and we can prove that that's true. Oh, actually, it's not in here. Info ID. Oh, yeah, marker info ID is what we would want to look at, isn't it? Let me have a look here. Yeah, marker type. Yeah, there's only two different types, right? there's player spawn point and actor spawn. But in the future, maybe there'll be others. I kind of built this to be extensible and then only end up using 2 of these. But we'll see. But yeah, marker. So a marker will either be, most of the time, it's going to be an actor spawning. It's going to be a thing to mark where an actor spawns. This is X and Y coordinate. You can see these are floating points. So this doesn't have to be, like, we could do multiple ones per tile and they could be at like little tiny little different offsets in the tile and stuff, right? I think in practice, we don't do that. I think in practice, this is always like something 0.5, something 0.5, so that the thing is in the middle of a tile. I think that's what the map editor does. But we could change it. It just ends up, yeah, it just ends up being looking right most of the time. Like maybe this is the reason why, say in Wolfenstein 3D, you just have a map layer of spawning objects. You don't bother to store the coordinates of them. Info ID, I don't know why this is a char. Like that's silly. But anyway, info ID, it should be like uint8, probably, right? Info ID is saying which marker info ID. So that's in here. Oh, actually, I've said I wasn't going to go into deep dive, right? But like these guys, right? These guys would generate, the script will generate structs for these and an enum that points to the members of the struct with names. And these will be sort of the names, right? Like blaster pickup or something. And that's what that is. That's what this info ID will be. And then spawn flags. This is actually, it's its own thing. Oh yeah, here we go. Yeah. So spawn flags, you can have none. And also, you know, obviously these can get added together, right? You can have none, easy, medium, hard, and def. Those are the only ones so far. These are reserved for some reason. I forget why. And then past def, there is more space. How big is it? 32. Yeah, so we have tons of space. I don't know where we're going to use it. Probably not. We're not doing a deep dive right now, but it's probably easy to understand what those would do. Spawn direction is this one. Yep. So this, when something spawns in, if it faces in a direction, so like if it's an actor, like if it's a monster or something, right, it's going to be facing in direction. And this is the direction that these are directions it could be facing in. Oh yeah, fog. Don't worry about this. This is like kind of, I think this is never going to get used again. We used to use distance fog. There used to be distance fog that was configurable per map, and that was used to kind of shade everything in true color when we were rendering sprites and level geometry. But that is gone now. Firstly, true color is gone. And secondly, that distance fog concept is gone because now we use light levels per tile, right? So we do use distance still, but we use distance plus light level per tile, and we use that to shift colors in a color map. And so we don't use, yeah, basically this is defunct. Map options. So this is, oh, sorry, hold on a sec. I'm not even doing it from the right direction, am I? I'm meant to be doing it from the map. So we looked at the markers. Exit name 1 and 2. This is the names of the exits. That we could add more exits in the future, but for now, the map format just supports having 2 different exits. This is like a file name for a map, right? So the engine knows which map to load when you exit through that exit, which map to load when you exit through that exit, right? It's pretty simple. The reason to have 2 and not just 1 is, and we might want to have secret maps where your secret levels, where if you exit through the secret exit, you don't go to the next mainline level, you go to a secret level, and then when you finish that, it dumps you out at the next level or the level after that, or who knows, right? It can make all different funny things happen. It's with this very simple mechanism. And then map options is what I was about to talk about. So map options here, we have this global fog, which is defunct, don't worry about it. We have skybox ID. So this is the sort of the texture that's going to get used to draw the skybox. And we showed that, I showed that in the previous episode. There's like kind of stars in the sky and stuff that gets drawn. It gets rendered as like a cylinder around the player. And then music info ID is which music track, right, will play during this map. And that, is that in here? Yeah, so there's a file here. There's just one test music thing for now. But they would all go in there. Oh, and Skybox is similarly, right? There's a file, Skyboxes. But this is also not really filled out very much yet. Those are kind of things that are getting pushed off a little bit later. I think when the first demo thing is more or less finalized, then we'll probably add a new music and a new skybox for that there. And then as we start making the real levels, we'll start adding more stuff in those. Okay, so that is basically the structure of the map format, right? Now we can begin doing a bit of a deep dive on heights in the engine. So ceiling and floor heights, right? These are the two layers of the map that have the ceiling and floor height information. Let's start the game. Change this over. There we go. So now we're in the game, right? You can see, well, let me just get rid of it. Like having that hang around. You can see these are different heights, right? The floor here is a different height to the floor here. Okay. And the floor here is even higher. It's so high I can't walk up to it. And up here it's really high, right? See there's windows up there. It's very high. That texture changed. I think the texture's changed since last time I was running through this. But it looks
Sorry, I can't help with that. You can learn more about logging your health data with Siri at apple.com.
Okay, be quiet. I don't know if Siri was audible in the recording.
Okay.
All right, shush. You need to be quiet. Okay, anyways. Yeah, you can see it's all different, a huge array. Oh, look, this is a staircase. This is a beautiful example. See, there's so many different heights, floor heights here, right? The ceiling heights, not that much ceiling height variation here. Actually, if you go indoors, you go see different ceiling heights, right? You can see these different ceiling heights. Look, a bunch of different ceiling heights there, right? Okay. So that's what ceiling and floor heights look like, right? Okay, maybe back in the editor. So that's what they look like in the, oh, yes, that's right. That's what they look like in the game. But what I was going to show you as well was, sorry, no, in the level editor, right? This is where you can really see them. So in here, at the moment, to swap between different modes, we press tab. And now we're in, does it show anywhere here? Yeah, so it says over here, floor height, right? And this is kind of color coded. Maybe it should be displayed on screen to make it more obvious, but you can see, like, if I use the eyedropper and I choose one of these, you can see up here the height changes, right? So this is in world units. So like this one is 3.8 off kind of bedrock. This is 3.0. So out here is lower. I think this is just the default. I don't think this has been set by the level designer. What is this? This is 3.8. This is 3.8. Yeah. It can sometimes be difficult to make out the color gradient. If I zoom in, oopsie, if I zoom in, does that make it clearer or less clear? Wait, where was that staircase? I want to look at this staircase. Yeah. Yeah, here we go. Okay, does that make it clearer? I don't know. Doesn't really make it any clearer, I don't think. But there's a staircase here. You can see we'll go from like 5 to 4.8 to 4.6 to 4.4 to 4.2 to 4, right? Okay. I think that's the default zoom level. So that's for the floor height, and the ceiling height uses the same kind of, so you can see like all over there's like pretty colors. This is another staircase, right? And this is a staircase, and this is a staircase. So I guess this would be like an S-shaped staircase, right? We'd start down here, we'd walk up here, we'd walk here, and we'd walk here. Okay, that's for the floor, and then the ceiling probably is more boring. Like we don't have stairs on the ceiling, right? So they're just big flat areas, except for if you saw when I was walking through the level, there was that arch. I think this is probably the arch. So we've got 6, 6.4, 6.6, yeah, 6.4, 6.0, right? So this is that kind of nice archway. And the exterior areas all have quite a high height, 12. That will be, so firstly, that means that we could, there's no ceiling, but these walls around the exterior and the walls here of the building, right? So these exterior walls that are kind of framing the whole map, and also the walls around the building will appear to be like 12 high. That'll be used as like the roof height for those tiles when those get rendered. If you remember from the previous video about rendering walls. Yeah. Otherwise, I mean, this is like, I like looking at the pretty colors and stuff. Oh, this is cool. Beautiful symmetrical thing. I'm not sure. Oh, I know what room that is. That's the room. There's like a sort of, it's not secret, but it's like a hidden area you have to get into to finish the map, I think. And it's very cool. There's like water in here and stuff. And lots of hidden enemies that you come upon. Okay. Did I explain sort of? Yeah, I think so. If we go back to the beginning of this, and I'll show you like, so that's the ceiling height. I can change, yeah, why don't I change that? So we'll select that and we'll go down a bit. We'll put this down to like 9, maybe, right? And then we'll paint this whole area. I think, no, I can just use flood fill. Yeah, that's beautiful. Look at that. Okay. So now if I do that, oh, look, this looks very wonky, but see, I changed it. So now over here, the height is still 12. Here, the height is 9. So this is lower, right? And then also, I think you can demonstrate it in... Oh, no, actually, that'll change the tile depth for everything. So we probably don't want to do that. But we can also change, like, the floor height, right? So we can make it so this is... Oh, the height of that is different again, is it? Oh, I don't know what the difference is there, but anyway, maybe it was just like very slightly different. But see, now I've changed it so I'm up higher than this guy. Yeah, I changed the floor height. That's kind of interesting. Let's see. I can't get back up there again. Lead. Okay. Yeah. That's pretty cool. Now we should be back to how we were before. I don't know if this is actually right. Oh, this is not right because we had this curve. Now I screwed up the curve. You can see that, right? We can fix that up though. Oh yeah, look at this. It was like very subtle. So we'll fix the curve up. Or actually, maybe it wasn't even, it was like this whole area here, maybe, right? Something like that. I don't know if that's actually visible in video. But... Oh no, okay, no, that's not right. I did too many. 2 tiles less, sorry. But you're seeing, like, I guess this is kind of good because it shows... This demonstrates exactly what it does. Yeah, now we're right. Okay, so we've got this curve that's too thick here and it goes down. The carpet here is just, I was messing around and I decided to put a carpet tile on the floor. It looks pretty funny. Okay, so that explains the height, right? That's a pretty good demo of the height. The next one is the light level, right? So let me just quickly ground that by going back into here. Going back into here. So the light level, right? This one here. Hopefully this can be faster. Light level is shown in a similar way in the game. Press tab again. I don't know if I probably cycled through this and people could have seen before, but anyway, this is what the light levels look like. At the moment, this level has had all the lighting removed from it by the guy who's making the level, which is fine. I'm sure it'll have really cool lighting again soon, but we can mess around with it. So I'll just take this. This 128 is in between. This is like, so I said it was 0 to 255, right? What 128 we treat as just like, it's just neutral. It's not dark or light. So we can, let's say we'll make some, actually we'll make, can I get back to 128? I'll make sort of like a gradient here along the wall to demonstrate. Going lighter won't really change anything because at a close, when you're close to something, 128 will look the same as anything brighter, right? Brighter than 128 is only going to make a difference when you're looking at something from a distance. So now if you look here, you can see, oh, wow, there's this cool gradient of darkness. And you can see, maybe we can demonstrate with the player. You can, if you look at the hands, right? The player hands will get, because we're standing on the thing, right? So we'll get made darker as we go through. And if we put an enemy there, so we can take this guy and move him here, say, right? Then now you can see he's darker there, right? Or we could take him and put him here. And we'll make him face north so he doesn't spot us straight away. He's just a little bit darker now. Yeah, it's a kind of cool effect. Okay. So that's what the darkness level does. I think that basically explains it, right? You saw just painted, just setting these dark, like light levels and painting them onto the map. We could do, oops, is that right? Yeah. It doesn't have any gameplay effect now, you know, like maybe you could imagine that it would, you can see now there's like this kind of gradient in like a circle around there. You could imagine, right, that you could use it to make it, to have some stealth mechanic based around it. It's not like that at the moment. It's just visual. Okay. So we finished with the deep dive on light level and height. The next thing I was going to talk about was serialization, deserialization. So that's exciting. That's a very exciting topic for me. And that's in a file called map file. Is this interesting? Kind of. The API for this sort of is just like read file, write file. Write file just returns a bool saying if we succeeded or not, and it writes to this path. Read file, it takes a path and it returns a pointer to. So this is dynamically allocating a new map. If I was implementing this now, I probably would do this differently. This is really old code from like right at the beginning of the project. That's also why I'm using C++ strings here. If you look at newer code, this is almost never done, or it is never done. I kind of gave up on using std strings pretty early in the project. But that's okay. Don't worry about that. That doesn't matter. I think, you know, people watching smart enough to know that it's the same. It's the C strings that I use in other places. There's no difference, right? And also the writing and reading a file is not something that we do thousands of times in a single frame or anything like that, right? It's something that happens very rarely. Okay. There's a whole bunch of these at the start. Yeah, okay. So this is important to talk about. So the structure of the file is kind of like this comment says. So we have a header which has a magic number that says what the file type is. and it has a version, although at the moment the version's not used because there's no public versions of the game out there. So there's no reason to change the version. We don't need to worry about compatibility. But in the future, that will be used to version the map files so we can let people make map files and not break map files and have sort of backward forward compatibility via the version. The magic number for my map format is this. It's highly secret, very tightly guarded secret. Don't tell anybody about that. And it's 24 because I started this at the end of 2024. And then after the header, there are chunks. The sort of schema for a chunk, the layout for a chunk is that bytes 0 to 3 inclusive are the size. So that's 4 bytes of size of chunk. Then 4 to 7 is the type of the chunk. And then onwards from there is the data. We've said what the size is here. And so what does the type of a chunk mean? I mean, size is obvious, right? It's the number of bytes. But what's the type of a chunk? The type of a chunk is like a 4 character, because this is 4, 5, 6, 7, 4, 5, 6, 7 characters like this that identifies which chunk it is, right? Now, in practice at the moment, I think I always write and read them in a particular order. And so when we write out and read back these chunk types, you don't actually use them for anything. But I like to have it there for the future so that the implementation of this can change to be more flexible and the format is still correct, right? All these files that were written out in a particular order are still correct. But if in the future we start writing out files where these are in different orders, we can just change the reader and it's all good, right? So there are some extra constraints that basically that aren't expressed here in the current reader, but they don't need to be there for the format to work. Okay, and then these are particular chunks. So the tile chunk is containing this stuff here, right? As I said, the layout of this is very similar to the layout on disk is very similar to the layout of memory. We have this chunk, then the floor chunk, which is this guy, and then so on, ceiling, light. This light one is light level. Then we have the tile depth chunk. I think this is slightly different. Is this different? No, it's not. Sorry. This is still the same as the layout as the map. So we have the count first, and then we have the tile depths themselves. Now, I'm not sure if we actually only write out the tile depths that we are using, or if we write out max tile depths every time. But we'll see that because we're going to look at serialization first. And then for each tile depth, it's like what you would expect, right? I didn't actually write it out in the correct format with like the sizes, offsets and stuff. Then marker, that's the same as, oopsie, don't pin that. Oh yeah, we could pin it, I guess. Yeah, maybe we'll pin that, why not? I've got pride of place at the moment. Yeah, this is marker, right? For an individual marker. Oh, I guess that's the same, similar format to what I did there. And then exit chunks, the exit chunk is like this, and it has 1 and 2, and then the map options has that stuff. This stuff is defunct. We could remove it from the map format, etc. It doesn't really take up any space, so if you don't have a follow. And then write map file, straight into it, write map file. This is what I was saying. We take in a map, we take in a string, we'll return a bool to say if we succeeded or not. I think the only case where we fail, let me double check. Yeah, the only case where we fail is if we can't open the file for reading, right? If we can't open the file to read, to write it. If we can't open the file to write it out, then we fail. Otherwise, we'll just go ahead and write stuff. There's no error checking here. Can these fail? Maybe these can fail. It's not showing me any. I think maybe it's because OBS is open. But anyways. This does return something. I don't know, maybe it returns, well, it can't return null, this returns a reference. So, no, I guess, yeah, this doesn't tell you from the return if it failed, but whatever, it doesn't matter. Don't worry about that. So yeah, first write the header. It's like exactly like this comment says here, right? We just go through and we do it in the exact same order. First we write out, and this wouldn't be wrong. If we made it so that you could randomize the chunk order, this write stuff wouldn't be wrong. This is just this is one implementation, right, where we choose to do it in this particular order. Okay. So we write it out, the header, and that's, is there anything funny here? So like I showed you, this is this one here, right? And the size of it is pretty boring. We just do size of that, right? Say what the size? Oh no, that's right. This is not showing any colors. And then for the tile chunk, we do the same thing. We do, let's see. We write out what the size of it is going to be, which is just the map width times the map height. And then we can just write out the entire, we can just write out the entire map in one go. Just that chunk of memory. We say the size of it is the size of a tile info ID. I don't know why I put uint16 and not tile info ID, but we'll just leave it. It's the same multiplied by width multiplied by height, right? Just write out that whole thing. And this is, so importantly, like this is an array, right? So there's no, it's not a struct. We don't have to worry about if the size of it is not really equal to this, because the size of the data really is equal to this because it's an array. Otherwise, you wouldn't be able to index stuff in the array, right? It's pretty important. Yeah, you probably wouldn't want to do something where you say the size of this thing is the size of field A plus the size of field B plus the size of field B, and then you mem copy the struct into it, or vice versa, or whatever, right? Like that's probably unsafe to do. Anyway, floor chunk size is add those things together, whatever. And then we do firstly, and by the way, this is safe because we know that we're going to write out exactly this plus this plus this, because that's what we do, right? Okay. So the total size is this. We write it out here to say this how big the chunk is, and then we in fact go and write exactly those. So that's correct. And then same thing, ditto for this, floor height, ceiling height, whatever, lighting. It's all the same, right? We've got this guy in the map file. He's W by H by 1 byte. And so we just literally write that out to the file with this fs.write. Oh, is there any reason to explain this? I don't know. This is C++ file stream stuff. It's like needlessly complicated. It is needlessly complicated, but I started out this way just because it was easy and this project is in C++. Maybe if I was going to do this again, I wouldn't use file stream. I would use something else. There's a few, like, what do you say, like kind of leaf nodes in my program where, because I'm using C++, I use the C++ standard library thing, even though it's a bit unnecessarily complicated, just because it's the path of least resistance. And you could just go and swap this out with some other way of writing to a file. If it became a problem. This wouldn't be a problem for cross-platform compatibility, I don't think. It could be a problem for like customization or memory allocations or something. But I think it's okay for now. And as I said, this is not something that runs like hundreds of or thousands of times a frame or something. This is just something that happens very infrequently, and it's right at the leaves of the application. It's not in the guts of it. So we use fs.write here. And I also don't want to be like casting shade on standard library or file stream or whatever. I guess I mean that it doesn't really, you probably look at this and think it doesn't really match the style of the rest of my program. It's not, I'm not using like modern C++ stuff in the program, but It's okay. We don't need to be curious about this stuff. Like whatever works. The reason that I do things the way that I do in other places is not for ideological reasons. It's because it just works better, right? And this works fine, so I don't have any problem with it. Okay. Right tdef chunk. Oh yeah, okay. So this is pretty big and huge, but it's just because there's so many fields in a tile def, right? And you could write out the tile def struct in one go. That's not the path that I started down here with these, so I don't do that. But you probably could do that, and it'll probably always be safe. You might be stuck not changing some settings to do with padding structs and stuff in your compiler. That might break compatibility for map files if you did that. That might be worrying about things that aren't very important, like what is it, like worrying about overpopulation on Mars or something. But this is the way we do it, and you can see that it's fine. It's a bit gross, but it's fine. We just write out one field at a time, where these types are not going to change, like the sizes. These can't possibly change. I'm going to argue. This, like, some of these things that are like in enums are a little bit dangerous. Like they could change size, and that would be a subtle bug. Like the compiler is free to make these bigger if it needs a bigger type to accommodate the number of things you've got there. Actually, but it already doesn't pick us. It already doesn't try to optimize it to be smaller anyway. So I think these already start off as like an int. They like start off as like 32 bits. So unless you went over, but you could go over 32 bits, right? Anyway, so that does that step by step, type flags, the key color, etc. Blah blah blah. And then writing markers is similar, right? We do for each marker, we write out each field one at a time. We write out, the size of the whole thing. We write out how many markers. Do we write out how many markers there are? Yeah, marker count we write out here, and all this stuff. Yep, that's all good. The write instructions themselves are fairly boring, I think. So we can look at the. Oh, we already looked at this, right? This is gross. Look at this. It's like, anyway, doesn't matter. But you can see we write out element. Wait, element. We pass in a pointer to the thing, the data that we're going to write out and how big it is. Stream. I guess this is stream and this is count. I don't really know why they use this. Oh no, it says, oh, insert count characters from array like string. That's funny. I don't know why they use this language. I'm not a full model on this kind of topic, I guess, but whatever. I think of it as like, this is a pointer where we're going to read bytes from, and this is how many bytes to read or to write. But we're not writing it to this pointer, right? The bytes get read from this pointer. They get written to this guy here, fs, right? The string. Anyway. So that's what each one of these lines, and these are all, yeah, that's what all, the whole function is just fs.write pointer to get data from, how much data to write, to read from there to write to the file. Do that over and over again, and then eventually close it and then return true. That's what I call serialization of a map file. That's what happens when, whoops, now I don't want that to be pinned. That's what happens when you call this function, and that gets called, for instance, like in the level editor when you save or when you close it. Okay. And now read map file is the opposite, right? There's a map file on disk somewhere, and we want to load it either to edit it in the map editor or to play it like actually in the game. And yeah, that's pretty good. Okay. And then we do just the opposite, basically. We create a file stream, same as before. If we can't open the file, then we fail and we return a null pointer. If we don't fail, then don't we need to create a new map? Yeah, we do it here. Okay, hold on a sec. So there's some interesting stuff going on. Oh, okay, yeah. So before we create, that's a good point. Before we create a new map file, we read the header and we do check if it has the magic number, right? So this is actually pretty sensible of me. We just read that first bit out just enough to see, is it, where is it here? Oh yeah, so we just compare we compare character by character, right? I guess that makes sense. We could reinterpret it as like a, how many things is it? Oh, you know what? Doesn't matter. What am I stressing about that for? We compare it character by character, and if not all the characters match, then we say it's not the right kind of file. Phew. We read the version here, but then we don't do anything with it because, like I said, we don't have any different versions yet, right? But eventually, this part and then all the reads underneath will become pretty spicy when there's different versions, right? And then we read tile chunk. That's just the opposite of what we did above, right? So we'll get the size of it and blah, blah, blah. We don't check. We just say we know that it's width by height, right? And I think I recorded a video a while ago where I changed the size of the map. And it was like hard coded in so many places. And then in the file format, it actually said what the size was. And I think maybe it even respected it, but it was never going to be different from some default value. So I was saying, oh, that should get cleaned up, that should get changed. And I guess I did that since I recorded that video. But probably people will see this video first, so it'll seem like I'm time traveling. Which is fine if you guys think I'm a time traveler. I don't have a problem with that. Is this do interesting stuff? What was the point of what I was saying here? Oh yeah, so like this is so simple. This is like dead simple, right? It probably seems like it's going to be complicated, but it's not. We just get a pointer to where the tile data is going to be, so the array, and then we just get this whole blob. Just shove the whole blob in there, right? Don't even look at it. Just cram it in there. That's fine. And same for all these other ones, right? Just cram it in that pointer. Just cram it in. There's no, don't look at anything. There's no loop. Just cram it in there. That's fine. And then tile def. Oh, but for tile def, we can't do that, right? Because tile def, these are structs, and we don't want to just blindly mem copy the struct. We want to actually copy it field by field. So we do have a loop here, right? We go, yeah, we read out how many there are, and then we've written that into num tile defs, and then we go through here and we read one at a time. For each tile def, we will go through and read field by field. So this is a little bit safer, right? I mean, this is not unsafe because these are all, they're all the same size, and the size of the thing that they are is never going to change. It's always going to be UN8. The other one's always going to be blah. Okay, yep, that's fine. Is there anything? Yeah, and also this is safe, right? So we go through and this tile def, this is an array, and we step through the array one tile def by one tile def, right? We use this I and we index it like this. So this is all safe. We're not going to end up with a corrupt tile defs here because we're using, like, on the reading side, we're using array arithmetic with the compiled struct of the tile def in the array and all in the same compiler, right? That's all good. Okay. And then read marker chunk, same thing, read field by field, and we're using, we're indexing into an array one by one based on the number of them. That's all good and all very safe. The exit names, I didn't talk about this before. They are precisely 128 characters, right? You can use all of it, you can use some of it. It's up to you. That's your problem, but we're always going to read and write 128, so we're probably reading and writing some garbage every time we do it. And map object is really boring. It's just a few things that are fixed size. The only interesting thing, like I keep repeating over and over again, is that this fog stuff is defunct. We don't use it anymore. Then we close the file stream, and then we return this map. Oh, did I talk about this? I think I skipped over it. We do here, we knew a map, and then we return the pointer. This is really stinky, right? But, or at least it's like, it's not consistent with the rest of the style of my program here. That's okay. As I said, this code is older, right? And we do delete this. I'll show you now. Am I running the game? I'm still running the game. That's fine. Doesn't matter. See, we do delete it. I promise we delete it. So that's okay. We delete it when we load another one. I think the last one that you loaded when you quit the game doesn't get deleted, but who cares? Like the operating system going to rip all this stuff, so that's fine. And you could put that in shutdown game. There is a game shutdown. Do we delete the map here? Nah, we don't. Why would we do that? Who cares? Okay, so hold on. That's deserialization. Yeah, serialization, deserialization. How simple is that, right? I mean, I guess nobody said that it was hard, but load map. No, not this load map. Read map file. Oh no, it's something that gets called after this. Load new game. Oopsie. Oh, screwed up. Maybe just shoot you. There we go. Is it in here? Init map? No, this is doing interesting stuff though. This is if it's a brand new map. This is cool. This is kind of like a bonus behind the scenes for you guys. If we create a new map and we haven't, and it's like no data in it, right? Like it's actually a new map file. We'll just fill it with, what will we fill it with? 0th tile ID. So it's like a default tile ID that has tile depth that has to exist in the beginning. And the floor heights are all 30, the ceiling heights are all 40, the light levels are all 128. And by the way, this is like fixed point number in 0.1 world units. So a height of 30 means a height of 3, and a height of 40 means a height of 4 in world units, right? And this, like we talked about, 128 means like neither dark nor light, like just neutral light level. Num tile depth has to be equal to 1 because we always have the 1 default one, otherwise the map format doesn't work. We do an init tile depth, which just makes a boring tile depth like this. It's all the textures are transparent and etc. Blah blah. It's an ugly tile, you don't want it. And let's see. Oh yeah. Fix map. That's interesting. Yeah, this is a console command I created, I think. Hopefully no one will ever have to use that. I haven't talked much about the console. That's fine. We'll do a video about the console, but it's not that interesting for these purposes. Init, so init map is not what we want either. What is it called? No, it's not in here. It's in game. I always bloody forget what the name of this function is. What is it called? It's like, I bet I can find it. Init new map. Init new map. I don't know why. I should go through and change the names of these so it makes more sense, because every single time I get lost and I can't remember what it is. Init new map, right? So this function, when you've loaded a map file and you're going to play it, right? You're actually going to play it as the player. We need to read a bunch of stuff, like for instance, the markers, and then set up a bunch of game state based on those markers, like spawn that actually create the enemies in the game world, and set them all up in initial states. This is not something we do every time we load a new map, even every time we load a new map to play it, because sometimes when we load a new map to play it, we're loading a save game. If you're loading a save game, you don't want to load all this stuff from the map file and do it, because, like, you know, a bunch of the monsters the player might have killed, or they might have moved somewhere else, or the player themselves might have moved from the spawn point. You don't want to place the player at the spawn point every time they load a new game. That doesn't make sense. So this stuff is stuff that only happens when you're loading a map for the first time. And we call it init new map, which kind of makes sense in that context. But to me, always makes me confused. I can't tell which one's which. Okay, so what do we do here? We'll start the music. Oh yeah, okay. So the reason why we do start music here and we also do start music elsewhere is that in the save game we can save what position the music is up to, I think, and maybe. Oh, initialize dynamic tiles. So that's something I talked about before. This is like, so it'll initialize all of the doors and the moving floors and the push walls and all that kind of stuff. That is different as well from when we load the game, because when we save the game, load the game, the state of all those things needs to be serialized and deserialized. So that's different from initializing them. If we load a save game, we won't initialize the state. I think what we'll do is like maybe something called like replay. Yeah, we'll replay push walls. Oh, I don't know. Oh, in fact, we don't even have we don't even have a function for that. Because I think what happens when we load a save game is we will just read out this like the state of the dynamic tiles as a big blob of data and then just blob it on top of the state in the game state. Replay push walls is a special case because that requires going through and painstakingly redoing everything that the push walls did because they're a bit nasty. Okay. Init dynamic tiles. Yeah, so init dynamic tiles, it'll set up all the dynamic tiles that are declared in the map in their initial states. So like all the doors will be closed, all the moving height things will be in the positions they started off at. All the switches. Oh, actually, switches are not part of that. But whatever. You can imagine it's all this map state is in the initial state. We create a player, initialize the player. That's pretty boring. You imagine it's just like give them whatever health they're meant to start off at the start of the map. Although in the future that will change. Actually, I don't know. Going from level to level, when you go from one level to another, you don't want all your weapons and your health and stuff to reset. So that's maybe wrong now, but that's something that's pretty easy to fix in the future. Add actor to map. So we add the player to the map. This has to happen in a particular way because of the block map, I think. Is that true? Yeah. So the reason that we have a separate thing, which is create an actor and then set the position on them as an actor and then add to map as separate things, is because of the block map or the actor map. There's a breakpoint set. That's fine. So we add adding them to the map. We'll go and look up where go and look up if there's an actor on that spot already, right? And it will, if there is, then we will set that actor's next to us. And oh, actually, no, it's the other way around, right? Firstly, what we'll do is the actor that we're yes, we do it the other way around. We'll make ourselves the start of it. So the new actor that comes in, we're going to say the block map points to that actor now, and whatever the block map used to point to, we point to that now. There's not a thing in the outline about that. Actually, that's not explained anywhere. So maybe let me just. I'll add that now. Game world state. Let's say because that's pretty important. This actor map we just added here, right? I promise we'll do a video about this. Well, I promise that I've added it to the list. So in the same sense that all this other stuff is a promise, this is a promise now too, right? Okay. Oh, wait a second. In the previous video, I said I was going to add color map to this, and I didn't do it. Oh boy, what have I done? Where should color map go? Drawing level geometry. It's not really any of these, right? But I'll put it in drawing level geometry, just because it doesn't fit anywhere else. Should it be in its own section about colors? I don't know. For now, I'll just leave it here. So you see, like I said, I was going to. Cool. I better get a move on with this video. It's becoming really long as well. But you know, there's just so many things to talk about, and it's so much fun. Okay, so that's why we do add actor map. Doesn't matter. There's move as well. Let's not talk about that now. Okay, so we've created the player. We put him on the map. We give him the default health. Oh, this is funny as well, but whatever. That can get changed in the future, right? When we've got campaign going. Let's see. What is this diff flag? Get diff spawn flag. Oh, this is my brain is not working right. This is to do with difficulty, right? So this is important. We talked before about some flags. Oh, I said I was going to do deep dive on all the settings. I need to get a wriggle on. This diff flag is like just to determine if we should spawn something based on the difficulty the game is set to. So if the game is easy mode and spawn is set to be hard, then we don't spawn it, right? That is pretty straightforward, right? Okay. Then in here, for each marker we go through, if it happens to be a player spawn point, and hopefully there's only one of these, because if there's more than one of these, then the order, yeah. I guess the last one will end up being where the player spawns, which is not the end of the world, but it's pretty bad if you've designed your map in that way. Like, that's clearly not intentional. We'll just move the player to where that is. And there's some special stuff, like what's interesting, we will set the height of them to the height of the floor where we've spawned them. It should be pretty obvious why we would want to do that, right? The markers don't say what height to spawn an item at. And the player should be on top of the floor, not in the floor or in the sky or anything, right? Rotation is just, because we store the rotation as this spawn direction, it's a number between 0 and 7. But the player is rotated in degrees because they can turn with the mouse and stuff, right? They can look around. It's not the same kind of thing. We have to set the player's rotation to be the spawn direction multiplied by this. So why is it that? I forget why it's minus, but that's not very interesting. But pi divided by 4 is like 45 degrees, right? And since we've 0 to 8, it's like, you know, what would you call those? Like northeast? I don't know. But anyway, it's 45 degree increments, right? So we multiply it by 45 degrees. Okay. And then for actors, if it's the wrong difficulty, we don't spawn them. Otherwise, we get the floor height. We spawn them at the floor height. Let's see. Spawn. We go spawn actor at. Does this? Yeah, this does add actor to map, right? So we've set the position here, and then this puts them in the actor map at the right place. So importantly, we don't move them here after we place them. We place them at a location, right? So they're correctly tracked in the actor map. Okay. And they're not freely rotating like the player is. So their move direction just gets set to the spawn direction. And then this is just isDef is isDef. isDef on a monster is not as interesting as it might sound. It just makes it so that they don't respond to hearing the player, like shooting a gun. They only respond to seeing the player. Okay, and that is everything to say about, I think that's everything to say about initializing game state from a loaded map. If, as I said before, if we're loading a save game, we just skip a lot of this stuff. We skip all the stuff from here, right? And then we just only look at the load game data. And the load game data, loading, serializing, deserializing save games is a different video, right? We don't worry about that here. But just suffice to say, obviously, is a lot less of this stuff. It's mostly going to be stuff from the load game. The stuff we read out of the map in the case that we load a save game is pretty much the level geometry and stuff about dynamic tiles, and that has to get merged together with the other dynamic tile stuff, right? Okay. And then the next thing to talk about is the deep dive on tile depth settings. So if we go back to the map file here, we talked about tile depth. We've got all these things. I talked about some of these already, right? Tile type is about if it's a wall versus a thin wall versus floor. The flags, we've got these flags that do different stuff. And I got part of the way through this, and then I said, oops, I'm not meant to be doing a deep dive now. So now we can talk about some of these, and we can also look at them in the map editor. And actually, maybe we should just go straight to the map editor, because I've already showed the code here, and the map editor says exactly the same stuff as the code. So let's just look at the map editor. Game is running. We're going here, and we've even got the map editor open. Okay, so I haven't shown yet, I think, this one. So if we can choose one of these tile depths. These are all the tile depths that have been created for this map, right? So we choose this one to start with, right? And look, this is all the same stuff that's in that tile depth struct that I showed you. We can choose a direction for it. It can either be north, south, or east, west. It doesn't matter for a floor tile. It won't do anything. Key color, it can be red, green, or blue. Again, it doesn't matter for a floor tile. Oh yeah, thank God my cursor shows up there, right? Okay. Tag, this is like the scripting stuff. Again, it won't matter. It can matter. If we had these, so this is like floor move, ceiling move, right? If these were set to stuff, then the tag would matter because the tag would say which switch this was tied to move it between the different heights. But tag 0 means this is nothing. There's no, you can't switch tag 0. Switch tag 0 is unswitchable, right? So if we did have a switch hooked up to 0, you could flip it on and off and nothing would happen. And so similarly, doors and floors and stuff don't get affected by that. And what else do we have here? Exit. This can't be an exit because it's floor, so it doesn't really matter. If it were a wall and it was set to an exit, then when you go on it, you go up to it and press like E or whatever interact button, then that would finish the level, right? That would be, you'd win the level when you do that. And these flags up here. Okay, so sound and vision. So if you check sound or you check vision, you're saying that this tile doesn't block sound or vision. That doesn't have any effect on a floor, but it would have an effect on a wall, say. If you want enemies to be able to hear through a wall, then or see through a wall, then you can check these. No ceiling. That if you have this checked, then you can see sky above this. If you have it unchecked, then you see the ceiling texture. We can demo this now. So at the moment, you see this magenta stuff is actually transparent. So this tile has no ceiling, but we can give it a ceiling. What should we give it as a ceiling? I think this is kind of pretty. We choose that as the ceiling, and then we will uncheck no ceiling, and then we'll load into the game. And then now, whoa, not everything. So you can see there's different kind of tiles out here. But see, now I have this ceiling above this kind of tile, right? And you can see it's darkened the same with the light level. We've got a ceiling over these now, right? And if I go back in and edit this one and put no ceiling back on, now you'll see there's no ceiling getting thrown above those, right? Okay. Door won't have any effect on a floor, but door will turn something into a door if it's got a mid texture and there is if it's got a mid texture and there is space to actually draw the mid texture, then there'll be a door there, right? Push wall will make something move when you use the use button on it. Maybe I can mess with that. I'll show. Well, let's do door first, and then I'll do push wall. So this over here at the moment is a door. Why does it have this funny texture drawn on it? That's not the mid texture, is it? Oh, I'm looking at the wrong tile. It's this one here. Okay. Yeah, see this, the mid texture is this door. It's set to door. If I change it so that it's not door, then it won't open and close anymore, right? And we just run over there and do that to prove it. See now, like I can go up and press, well, I guess you don't know. I'm pressing the use key and nothing happens, right? It doesn't actually use it. Okay. And if I go and turn door back on. Oh, and you could probably see as well, I'll show you in a sec, but the sound flag is turned on there. So because these are bar doors, the enemies can hear through. They'll get alerted, I think, if they're close enough. Yeah, see, that guy got alerted. And now I can open the door. Oops. Yeah, cool. Cool. So they can, maybe they should be able to see through it as well. I guess it's arguable. Don't worry about that. Oh, let's get away from that. Okay, and then I will... This is back to being normal, right? Yeah, okay. Yeah, so that's how door works, right? Also, we could make a push wall We can make one of these things a push wall. I wonder though. I'm not sure what's going to happen. If I choose this and I make it a push wall, will all of them move at the same time? Oh, no. Okay. That crashed the game, did it? Okay, oops. Let me start that again. Oh, yeah, hold on a sec. The level is blocked now because of that. I need to spawn into the level editor. Let me go and just hack something quickly here so that we can spawn directly into the level editor. But that's something that needs to get fixed. So at the end of, oh, actually, let me show you. You can see the code while I'm doing this. See me just quickly hacking this. But at the end of this, let's go load player scene. Let's go load map editor. No, what is it called? Level editor? Or just called load editor? Is it load editor scene? Okay. Let's see. Does this work? Can I just go directly into the editor scene instead? Okay, you guys can see that worked. So maybe that should be some option or something. But you see this guy here, this is bad. Don't do that, kids. Okay, we'll turn push wall back off again. And then now, yeah, now that's all good. Okay, so don't do that. I want to show a push wall though. Are there any? There are push walls in here. I guess, oh, actually, you know what? I can just do that. I'll just move instead of creating one and messing around with it, I'll just move myself to like here. And then now, when I spawn in, let's turn God mode on. Give myself guns so I can kill these guys. Get out of here. There you go. Whatever. Where was the push wall? I forgot now. Like here? Yeah. Ah, there you go. Yeah, you can see that's how push wall works, right? Cool. And then, oh, that looks kind of out of place. I don't know why that is like. Oh, I guess because it has a rocket launcher, right? That's pretty cool. But rockets seem to move too slowly. I should make them move faster. Look at how slow it is. Anyway, that's push wall, right? And you know what I could do is I could just delete all these guys, right? And then they can leave me alone. There you go. And I can show that again. The push wall here, you can see it looks like a normal wall, and then I go like this. And then it's like that. And you can't use it anymore after that happens. But if I go in here and I choose this one, and I make it not a push wall, right? Now it doesn't do anything. So, and also, what is it, like this? Yeah. Oof. Yeah. Otherwise, it'd be so hard to tell which one was the different one. So this is a 27. You can see it's different from the others. We'll go in and change it to be a push wall again. Now we can turn that off. Yeah. Otherwise, we have no hope. Cool. Okay. So that's what push wall does. That's what door does. Switch makes something a switch so that you can turn it on and off. Can I find a switch already in here somewhere? There are switches. I know there's switches in here, but that's such a chaotic thing. Is there a switch in a simpler location? I forget. Oh, there's switches in the elevators, right? But is that too complicated? Where is the elevator? Where are the elevators at? Here? Here's elevators. Okay. Oh, I'm gonna move my spawn point over to the elevator. Can I do? Oh, that works. Ah, that's cool. I didn't even anticipate that, but yeah, that works like that. Okay. So now if I go here, Oh, somebody's mad at me. Who's mad? Oh, what? I don't know what that was from. Anyways, something. Oops. Let me go through here. Whatever. And click back off again. Here we go. This is a switch. This is a switch here, right? There's one on the other side as well. Okay, so this is a switch. If I flip this, the elevator gonna move up. Let's see. It would be nice to have a simpler example. There we go. We've gone up in the elevator. Hopefully no one's going to harass us here. Okay, so what was the point of that? Oh, was to just show what happens if you turn switch on and off, right? So which one of these was the switch? This one here is the switch, I think, right? Yes, this has switch turned on. If I turn that off, then the switch won't work anymore. Let me just delete these guys. And oops, and move myself here. Okay, so now when I spawn, I'll be next to the switch, and I can go here. Oh, no, it's not right. Cool. Go here. I'll turn it off so it's not switch anymore, and you'll see. Okay, but anyway, now it looks like a switch, but doesn't do anything, right? Go out here, turn switch back on. Now I go in here and you can't switch it again until it's finished what it's doing. So it's going to do whatever it does. I'm here. Now it's finished. Now I can switch again and it'll send me back down. Yeah. Okay. So that's what switch does. What else is in here? Exit. Oh, yeah. Exit is like a level exit. Fake wall. Oh, fake wall is defunct. Don't worry about fake wall. Height mover is the thing that makes things go up and down. Why is height move turned on for that tile? Oh, it moves along with you. Oh, that's right. It does. It moves along with you, right? With the elevator moving up and down. That's true. That's clever. I guess that's necessary for the elevator to work, right? Well, it depends on the kind of elevator, right? Anyways, okay. So that moves with you up and down, and this one as well, right? Exactly the same. Yeah, so you look at these two tiles, they both have exactly the same height move set on them. Let's see, we can change it to demonstrate height move. Why don't we say we'll turn off height move on the switch so that when you go in, you can flip the switch, then the elevator will move, but the switch won't move with you, right? So we'll turn off height move on that, and then now we'll go in here, and we'll go in the elevator, flip the switch. Oh no, now the switch is going away from us. We don't have switch anymore, right? And then when we get to the top, I guess we'll be stuck. We can't. Oh, can we get down? Oh, we can. Even though it doesn't visually look like it, you can still switch it. That's maybe a bug. I don't know. Maybe that's a feature. But you can see the difference there, right? Cool. And we'll turn that back on so that I don't get confused in the future. Let's see. What else have we got here? That's it. Oh, there's direction. So direction is important for like a door. So we've got this guy here. I keep spawning. Let's fix that once and for all, or at least for a little while. We'll make us face east. So now when we spawn in, we're facing the elevator. Okay. So we've got this door. It is a what? A north-south door, I think? Yeah, it's a north-south door. Because you see here, this line is going north-south, right? So it's a north-south door. If I change it to being a east-west door, you can see now the line is going that way, right? They go into the game and look at this. Oh, all the doors got switched and these guys can see me through here now. That's very funny. That's a very funny unintended consequence. But you can see how the doors got screwed up. Now if I open it, it goes that way. It's very strange. These doors are all screwed up. Oh, I didn't want that. There we go. I'm going to turn these. Yeah, so these are all the same tile depth. Like I was talking about, tile depth can be applied to any number of tiles in the game, right? So these doors are all the same tile depth. So if I change one of them to being east-west, then they all become east-west, right? So change that to north-south. Okay, so now it's correct. We'll go back in here and you'll see. These guys can't see me through the door anymore because the door is facing the right direction. And yeah, it's pretty much just used for thin walls, I think. Or maybe, is it used for push walls? I don't think it's used for push walls. Just the thin doors. Then we've got different key colors. Do any of these really use keys? I think they do. There's a door somewhere that's using a key. But I don't. Oh, these ones. These use a key, right? This is a key door. And it has a color. It's a red key. So if you try to get through there and as a player and you don't have the red key, it'll stop you. But if you set the key to none, or if you set it to a different key and you have a different key, then it'll let you through. We can do that now, I guess. I'll just go... actually, they're facing opposite directions. They can't see me if I move my spawn point over there. I just don't want to get harassed by monsters, but... Move myself over here and set myself facing south. Now, I can't get through these doors because they have a key lock and I don't have the key. Okay? But if I go in here and I remove it, make it key none, right, here. Now I can go in and get murdered. Okay, well, let's not do that. Maybe it's better if that door stays locked, right? Key red. Okay, so now back to red. Tag is used for scripting stuff. I think I don't have enough time to really show off the scripting of tag now. That's kind of a bigger topic and it will be complicated. Exit, similarly, like exiting between maps, that would be kind of a hassle to set up right now. I don't know if this map even has an exit at the moment. Maybe it does, maybe it doesn't. Who cares? And then, oh, this is interesting though. This is like the different textures, right? So low wall texture, mid wall texture, high wall texture, floor, ceiling, and then door frame. Does this have a door frame texture set? Yes, but the door frame texture... Huh. Yeah, I think maybe the level editor set these up wrong, but that doesn't matter. Or did he set it up right? It doesn't matter. These get used for different stuff. I think I discussed it in the previous video, but I think a good place to demonstrate those different textures is actually here. Yeah, so you can see this is on this tile here, right? This tall tile. We've got all three set. We're using low texture, we're using this one. Mid texture, we're using this glass pane thing. Upper texture, we're using this brick. And actually, we don't use floor and ceiling because it wouldn't make sense, right? If it's a wall, you're not going to see a floor and ceiling anyway, right? Okay. And then if you look here, if we go in here, this one, you'll see what I was saying. Low texture, we're using this gray one. Mid texture, we're using this window. High texture, we're using the brick. And these ones you don't see, right? That's fine. Now, for a different example, if we go into some interior, let's say like here, and we'll take a look at like this tile. Oops. Take a look at this tile here, this gray tile. It has floor, gray thing, ceiling, brown kind of stuff, right? And you'll see floor is this gray stuff, ceiling is this brown kind of stuff, right? So those are the two different textures that are being set on this tile. And the wall is not getting used. It could get used if, so actually that's a different example to look at. It could be getting used if there are, make ourselves face west. It could be getting used if if it's a floor that also you see the side of because there's a height change, right? So this one here, all right. There's a height change here, right? So the floor is this one, and then the side is this one. Is that the same texture? I think it's a different texture. We'll have a look. This guy here, right? So the floor is this dark gray one, yeah, and then the sides are this kind of different lighter gray thing, right? So that's how you get that effect. Like it's a wall, the sides of the walls, the lower wall is this, and then the floor is this stuff. Yeah, so those different textures get used for different drawing different parts of the tile in the camera. And then these ones are like the amount that the floor or the ceiling moves. Positive numbers are moving up, negative numbers, positive numbers are moving up, negative numbers are moving down. And the replace ID, like I talked about previously in the video, that's like what we replace something with in a push wall. You'll see, where is the push wall I was messing with before? This guy here, he will actually have something set there. Oh, I already showed it. Yeah, 2. So it gets replaced with tile number 2. You look in the palette, this is 0, 1, 2. It gets replaced with this guy here. Oh, that makes sense because it's this same, that's this guy, right? Yeah, so that's set up correctly. Yeah, so 2 means it gets replaced with this thing, which is what you would expect it to be, right? And then this tile will move 1, 2 to here. I think this push wall will move to here, and then there'll be empty tile here around it in a circle. Well, not in a circle, like in an arc around it, there'll be empty stuff, and this one here will be filled. Okay, so that's, let me double check my deep dive on tile depth. Oh, marker settings. I didn't do that. Yes. Okay. Well, we've already messed around with marker settings a little bit so far, right? Because we kept messing with this guy, this poor guy. Let's make him face west. No, make him face east, so he's facing away from us. And what can we change? There's not very many things. We can change difficulty, easy, medium, hard. We can make him deaf. That's interesting. So we messed around with spawn direction a lot, right? So I made him face that direct. Make myself face a different direction as well. Make myself. So see this little arrow is pointing to the left. That means it's west. Make it point to the right means east. Now we're facing the same direction as this guy. You can see he's facing that direction, right? If I change it, I can make him face north. And I'll move myself here to make sure that he doesn't see me. So, oh, wait, I didn't change him. Make him change. Face north. There we go. Oh! He still could see me. Let's move him a tiny bit. There we go. Now he can't see me. And he's facing north. Let's see. Actually, I should maybe change the light level a bit. Yeah. So now it's easy to see he's facing north, right? So there's not many things you can change on an accurate mode. There's not that many things that we need to worry about. There's the difficulty. The depth is a different thing as well. It looks like a hammer and sickle or something when it's zoomed out like this, but that is, when you look at it really close, you can see it's like a little no music note thing. It's so hard to see. It should be changed to something else. But anyways, if we load in now, you'll see what it means that this guy's deaf. So, right. We could even, and it's never going to wake up and attack us, right? But hold on a sec. But if we change it, we'd make him not deaf. And I do this. Now he's going to get mad. Oh, that was pretty rude. Anyways, yeah, so that's, if he's not deaf, that's what that means, right? And that's it. That's all the marker stuff. I was thinking there was going to be more stuff on marker settings. Yeah, so I guess that covers everything to do with the map format, basically serialization, deserialization, what all the different stuff in the struct means that you can do, what the structs mean, when we load a map from new, how we like instantiate like the game world with the data that's in the map, the representation of the geometry, what all the different textures you can set on things are, ceiling, skybox, stuff like that. And that's about it. Yeah, cool. I'll swap back to the, actually I can swap back to that and then also swap back to this. So thank you guys for coming with me on a walk through the code and a little bit of a demo of some of the different features of the game, or the engine. Yeah, once again, I've been your host, Nelson, on Programming for Posterity. Please, any questions? I'm sure there's probably lots of things that I didn't fully explain or that could have been explained in a different way. Please put your questions in the comments and I will look forward to reading them and addressing them in future videos. I hope this was entertaining and I hope it's kind of useful. You learned something. It was maybe thought-provoking about what you can do with the Raycaster engine or anything like that. And I look forward to seeing you next time on Programming for Posterity. Until next time, have a good one, guys. See you later.